Welcome to the series of e-learning modules on Boxplot. In this module, we are going to cover the definition, utility, construction and analysis of Boxplot as a graphical tool of representation of data. By the end of this session, you will be able to explain what a Boxplot is, explain the uses of Boxplot, explain the construction of Boxplot for the given data, explain the analysis and interpretation of the data. In descriptive statistics, it is assumed that data points are clustered around some central value. Hence, the data are generally summarized around these values. A Boxplot, also known as a Box-Whisker plot, is a good way for visual representation of summarized values of a data set. Let us first understand the meaning of Boxplot. A Boxplot displays the range and distribution of a data along a number line. It is a convenient way of graphically depicting groups of numerical data through their 5-number summaries. Boxplots can be drawn either horizontally or vertically. Now, we will find out when we should use a boxplot. Boxplots are particularly useful for comparing distributions of the results from several experimental conditions. A boxplot helps in indicating which observations might be considered outliers. A boxplot tells the spacing between the different parts of the box and helps indicate the degree of dispersion and skewness in the data. After understanding the use of boxplot, let us now understand the parts of a boxplot. Title. The title briefly describes the information that is contained in the boxplot. Number line. A number line is a line representing the range and distribution of the data. Box. One or more boxes are plotted in a graph, each representing a cluster of data. A box is formed by connecting the lower quartile, median, and the upper quartile. Whiskers. Whiskers on either side of the boxes represent the minimum and maximum samples. They are lines joining the box and the extreme values of the data. Legend. The legend provides additional information about the documents like where the data came from and how the measurements were gathered. Let us now understand how a boxplot can be constructed for a given data. A box-and-whisker plot is made of one or more boxes, each representing a cluster of data, and whiskers on either side of the boxes representing the maximum and minimum samples, which are then drawn on a number line to depict the data. In a box-and-whisker plot, the concentration of data is divided into 2 quartiles based on medians. The concentration is then visually depicted using boxes and the line connectors. Boxplots are depicted using the 5-member summaries of numerical data. These summaries are the smallest observation, lower quartile, the median, upper quartile, and the largest observation. Now, let us know each summary. The smallest observation. This is the smallest data point in the data set and called as the minimum value of the data set. It is the first value in an ordered set of date. Lower quartile or Q1. This value divides the distribution in such a way that 1/4 of the total items fall below it and 3/4 fall above it. If there is no middle value in the set of data, use the average of the two middle values of the data. The median or Q2. This is a value of the distribution which splits the series into two equal parts. One part comprising all the values greater than the median and the other part comprised of values less than the median. If there is no middle value in the set of data, use the average of the two middle values of the data. Upper quartile or Q3. This value divides the distribution in such a way that 3/4 of the total items fall below it and 1/4 of the item falls above it. If there is no middle value in the set of data, use the average of the two middle values of the data. The largest observation. This is the largest data point in the distribution and is called the maximum value of the data set. It is the last value in an ordered set of data. Now, let us discuss the steps involved in the construction of a box plot. Step 1. Ordering the data. This is the first step in constructing the box plot, wherein the data is arranged from the least to the greatest value of the distribution. For example, in a given data set, 15, 21, 47, 55, 78, 65, 56, 6, 19, 38 and 24. It is ordered as 6, 15, 19, 21, 24, 38, 47, 55, 56, 65 and 78. Step 2. Finding the median that will split the data into two equal halves. For example, for the same data set taken in step 1, we will get the median as 38 with the data from 6 to 24 in the lower half and 47 to 78 as the upper half. Step 3. Finding the lower quartile, that is the median of the lower half of the data set. Example, in continuation with the same data, we will get 19 as the median for the lower half of the data set. Step 4. Finding the upper quartile, that is the median of the upper half of the data set. Example, using the same data set, we will get 56 as the median for the upper half of the data set. As step 5. Identifying the extreme values of the data, that is the maximum and the minimum value of the data set. Example, in the same data set, we can identify 6 and 78 as the extreme values, 6 being the minimum value and 78 being the maximum value. Step 6. Plotting the graph. In this step, first we plot the 5 values above a number line. Here, we have plotted the 5 values, that is 6, 19, 38, 56 and 78. Then we draw vertical lines through the lower quartile, median, and the upper quartile. The lower quartile is 19, median 38, and upper quartile is 56. Next, we draw a box by connecting the vertical lines drawn through the lower quartile, median, and the upper quartile. Next, we draw the whiskers from the extremes to the box. The extreme values are 6 and 78. Let us now learn how to interpret a box plot. While interpreting the box plot, we need to keep in mind a few points. First, we need to know that by finding the middle values of the data set, we have divided the data into 4 equal groups called quartiles. In this example, the first group is 6 to 19, second group is 19 to 38, third is 38 to 56, and the last group is 56 to 78. We use the medians for comparisons of the data. The data with a higher median is considered to be a better data. Along with this data, let us consider another set of data whose Q1 is 21, Q2 is 40, and Q3 is 58. Since this set of data has higher median, it is considered to be a better data. We will be able to compare the lower and the higher values for any two sets of data. The box and whisker plot may include a cross or an X, marking the mean value of the data. In addition to the line inside the box that marks the median, the difference between the X and the median line can then be used as a measure of skew. In the first set of data, the mean value is 38.54 and the median is 38. Therefore, the skew is measured 38.54 minus 38. That is equal to 0.54. Similarly, the second data, the mean value is 4.18 and the median is 40. Therefore, the skew is measured as 0.18. The IQR is the length of the box in your box and whisker plot. An outlier is any value that lies on more than 1.5 times the length of the box from either end of the box. That is, if a data point is below Q1 minus 1.5 into IQR or above Q3 less 1.5 into IQR, it is viewed as being too far from the center value to be reasonable. Example 1. Let us consider an illustration to understand the concept of outliers. Find the outliers, if any, for the following data set: 6, 15, 19, 21, 24, 38, 47, 55, 56, 65, and 78. Solution. First, we have to find the IQR. Q1 is equal to 19, Q2 is equal to 38, Q3 is equal to 56. Then IQR is equal to Q3 minus Q1. IQR is equal to 56 minus 19, which is equal to 37. The outliers are Q1 minus 1.5 into IQR, which is equal to 19 minus 1.5 into 37, which equals minus 36.5. Q3 plus 1.5 into IQR, which is equal to 56 plus 1.5 into 37 equals 111.5. Therefore, any value falling below minus 36.5 and more than 111.5 are not found in the given data. Example 2. Let us consider an illustration to understand the concept of outliers. Find the outliers, if any, for the following data set: 10.2, 14.1, 14.4, 14.4, 14.4, 14.5, 14.5, 14.6, 14.7, 14.7, 14.7, 14.9, 15.1, 15.9 and 16.4. Solution: to find out if there are any outliers, first we have to find the IQR. There are 15 data points, so the median will be at position 15 plus 1 divided by 2, which is equal to 8. Then Q2 is equal to 14.6. There are 7 data points on either side of the median. So, Q1 is the 4th value in the list and Q3 is 12th. Q1 is equal to 14.4 and Q3 is equal to 14.9. Then IQR is equal to 14.9 minus 14.4, which is equal to 0.5. Outliers will be any points below Q1 minus 1.5 into IQR, which is equal to 14.4 minus 0.75, which is equal to 13.65, or above Q3 plus 1.5 into IQR, which is equal to 14.9 plus 0.75 equals to 15.65. Then the outliers are at 10.2, 15.9 and 16.4. Let us do a real-life exercise. Let us look at the following data depicting basic salaries of same class of employees of a company. Now, let us assume that the company is planning to do a salary revision exercise. Typical to all companies have a range of salaries that are being ordered to the employers. In the case, the range varies from 7,000 to 12,900. The company wants to know how the employees are distributed across the range, that is, whether they are evenly distributed with varying salaries or more concentrated in one range or towards lower or upper sides. Step 1. Ordering of the data. Since the salary data is in focus, the first step is to sort the set of data by salaries. Here is the sorted list in ascending order of salaries. Step 2. Find out the medians. There are 13 values in this ordered list. The 7th will be the median, that is 9,800. Let us call this Q2. The median divides the data into two halves. Step 3. Find the lower quartile. The median for this half will be sum of midpoints, that is 7,500 plus 8,000 divided by 2, which is equal to 7,750. Let us call this as Q1. Step 4. Finding the upper quartile. The median for this half will be sum of midpoints, that is 12,200 plus 12,800 divided by 2, which equals to 12,500. Let us call this Q3. Step 5. Finding the extreme values. The minimum value for this data will be 7,000. The maximum value for this data will be 12,900. Step 6. Plotting the graph. In this step, first we plot the 5 values 7,750, 9,800 and 12,500. The graph will now look like this. Then we draw vertical lines through the lower quartiles 7,750, median 9,800 and the upper quartile 12,500. Next, we draw a box by connecting the vertical lines drawn through the lower quartile, median and the upper quartile. Next, we draw the whiskers from the extremes 7,000 and 12,900 to the box. Interpreting box and whiskers charts. In this example, what does the box chart tell us? The plot tells us several things. There is a larger concentration of data points in the upper quartile. This means that more employees are concentrated on the upper salary range. There is a larger concentration of data points outside the box. This means quite a few employees are farther from the midpoint salary level. Even distribution of salaries can be achieved by bringing up the salaries in the lowest quartile. This will also be the most economical approach for the company. Considerations for making box plots. We have used a plotter chart in this example. However, this is not mandatory. You can use any other type of chart. In fact, it is not mandatory to show the data points within the box at all. All we need to show is 5 summaries. That is, sample minimum, lower quartile, median, upper quartile and sample maximum. In the example discussed earlier, we had prepared a vertical box plot. However, boxes can be plotted vertically or horizontally as per your convenience. There is no color code prescribed for box plots. You can choose what works for you. If required, multiple boxes, each representing a unique data set related to same matter, can be represented in same graph, each with its own whiskers. See this example. Key usages of box plots. Box and whisker plots are used for a variety of purposes in our daily lives. Some examples are policy making. To determine the most deserving segment to benefit from policies. 2. Financial decision making to determine the most economical actions to achieve the objectives. Understanding of imbalances. For example, social and economic conditions across regions. Let us discuss the advantages and disadvantages of box plot. The advantages are: handles large data easily. Due to the 5-number data summary, a box plot is able to handle and present a summary of a large amount of data. A box plot consists of the median, which is the midpoint of the range of data, the upper and lower quartiles, which represent the numbers above and below the highest and lower quarters of the data, and the minimum and maximum data values. Organizing data in a box plot by using 5 key concepts is an efficient way of dealing with large data that is too unmanageable for other graphs, such as line plots or stem and leaf plots. Summarizing. A box plot is a highly visually effective way of viewing a clear summary of one or more sets of data. It is particularly useful for quickly summarizing and comparing different sets of results from different experiments. At a glance, a box plot allows a graphical display of the distribution of results and provides indications of symmetry within the data. Outliers. A box plot is one of very few statistical graph methods that show outliers. There might be one outlier or multiple outliers within a set of data, which occurs both below and above the minimum and maximum data values. An outlier is an obscure result that can be detected by extending the minimum and maximum data values to a maximum of 1.5 times the interquartile range. Any results of data that fall outside of the minimum and maximum values are considered outliers, which are easy to determine on a box plot graph. The following are the disadvantages of a box plot. 1. It is not as visually appealing as other graphs. 2. Exact values are not retained. The issue with handling such large amount of data in a box plot is that the exact values and the details of the distribution of results are not retained. A box plot shows only a simple summary of the distribution of results, so that it can be equally viewed and compared with other data. For a thorough, more detailed analysis of data, a box plot should be used in combination with another statistical graph method, such as a histogram. Here is a summary of our learning in this session. Understanding of what a box plot is and its usage. How to segregate and prepare the data for constructing the graph. A detailed understanding of representing the summarized values in the data. In-depth knowledge in understanding its application.